if anyone else knows about momentum and impulse. You know what, I should do a project with Sharky. Yeah, I'll do that. Stop it. No, I'm gonna call Sharky right now. Oh, hey Sharky. Wait, what about momentum and impulse? Dude, I was thinking the same thing. No way. Alright, no. Alright, tomorrow, alright, bye. That was awesome. Sharky's awesome.
Hey, excuse me. We're just doing research for one of our projects. We were wondering how much you knew about momentum and impulse.
Nothing?
Explain momentum and impulse to me.
I don't know.
Excuse me, tell me what you know about momentum and impulse. Sorry. Tell me what you know! Tell me!
Due to the involvement of law officials, Tyler Sharkowitz is not allowed to interview locals anymore.
Oh, sorry. Well, due to our recent observations, we've come to the conclusion that nobody knows anything about momentum and impulse, so we're here to explain.
Through reliable sources, we have discovered what momentum and impulse are. We discovered that momentum is the symbol P, which is simply mass times velocity. And when you have no outside force acting upon it, your initial momentum is the same as your final momentum. Impulse is a little different, or it's not a little different, it's the same pretty much. It's just change and momentum, and that you can use two equations for that: mass times the change in velocity, or you just use force times the change in time, or time in contact with. Tyler Sharkowitz is not here right now because he's being investigated by the police for his extensive aggression with his last interview. To the left is Devin Lewis with a mass of approximately 45 kilograms and a velocity of 1.5 meters per second. To the right is Nathan Pezzi with a mass of approximately 34 kilograms and a velocity of 3 meters per second. Who has the most momentum, Devin or Nathan? What is the total momentum? If both Nathan and Devin continue and collide, and after the collision Nathan is moving 0.5 meters per second in the opposite direction, what is Devin's velocity? Who has a greater impulse? First, we need to find out who has the most momentum. To find the momentum, we use the formula mass times velocity. So we do 45 times 1.5, and that equals 67.5 p. Now we do 34 times 3 equals 102 p. So Nathan has the most momentum. Now we need to find the total momentum. To find the total momentum, we need to add the two together. But since they're going opposite directions, we need to use one as a negative. We can use either one. For example, we'll use Devin as the negative because this is a smaller number. So we will do 102 plus and negative 67.5, which equals 34.5 p. Now we need to calculate Devin's velocity after both Devin and Nathan collided, and Nathan traveled at 0.5 meters per second in the opposite direction. Now since Nathan traveled 0.5 meters per second in the opposite direction, it's going to be a negative 0.5. So, and due to our final has to be the same as our initial, we had to use 34.5 equals, and we need our momentum for Nathan, so it's a negative 0.5 times 34 plus Devin's momentum, which is x times 45. Do simple math. Plus 45x. That's going to be just do basic algebra. Oops, divide everything by 45, and x equals 51.5 divided by 45 meters per second, which equals 1.14 meters per second. Okay. Now we need to calculate who has a greater change of momentum or a greater impulse. So we'll check Devin. We'll use the equation mass times the change in velocity. We will do 45 times our final velocity minus our initial velocity. 2.64 times 45, and we get 118.8. Now we'll be finding Nathan's impulse. We'll do 34 times negative 0.5 minus 3, and that's going to be 34 times a negative 3.5, which is a negative 119. So Nathan had a greater change of momentum or impulse. People know now. People know. Right, Sydney? Where's Sharky?